Okay, I'd like to talk some more about different relationships between lines. When we talk about two lines, they can either be parallel, perpendicular, or oblique. Another possibility is actually that they are the same line. So when we talk about the relationship of two lines, they can do one of two things. Either they'll never, ever touch, okay? And we've been talking a lot about those in Unit 3. Those would be our parallel lines. Or they do touch, okay? When they touch, we call them intersecting. So in the situation where they do touch, we have two situations here. One is that they are perpendicular. And the other situation is that they would be oblique. So let me define these. I'm going to use some pictures to help define them. Parallel lines never touch. The orientation does not matter at all. Okay, they could look like that. They could look like that. Doesn't matter. Parallel lines, the symbol for parallel lines is they'll have little arrows on them. If you see these arrows, you know they're parallel. If I want to show these two are parallel, I might use two arrows on these since I've already used one in the other ones. Okay, so those are two sets of parallel lines. Perpendicular lines, those touch, and very specifically they touch at a 90-degree angle. Okay, there's one situation. Again, the orientation doesn't matter, but I'll show you a second one. Horizontal and vertical, perpendicular lines. Okay, so either they don't touch or they do touch. If they do touch at 90 degrees, it's perpendicular. Anything else we call oblique. So these would be oblique. Okay, I'll give you another situation. They're touching, but they are not touching at 90 degrees, anything other than 90 degrees. Okay, so let's talk a little bit more about these relationships and how we can see them. The easiest way to see it is actually by their slope, and if we're justifying it, we definitely want to use their slopes. Okay, we can look at two lines and say, yeah, they look parallel, or yeah, they look perpendicular, but we want to justify it using their slopes. So here's what we know about parallel lines. If you think about what slope means, it's the rise and run of a line, the rate of change. So if two lines have the same rate of change, the same rise and run, they're going to be parallel. Okay, that's always true. So parallel lines, their slopes are the same. Now perpendicular lines, well, first of all, if this is kind of a special case, our horizontal and vertical lines, those are always perpendicular to each other, horizontal and vertical. We can't really talk about their slopes because remember, a vertical line doesn't have one. But in all of our other situations, we can talk about the slopes. Notice one line will be rising and the other one will be falling. So their slopes are going to be opposite. Okay, so one will be positive and one will be negative, but they're also going to be reciprocals. Okay, that's when you take a fraction and you flip it. Okay, very technical word there, flip. Turning a fraction upside down. Okay, so if they're not the same slope, and they're not opposite reciprocals, anything else is going to be oblique. Okay? Alright, so let's look at some examples. One thing we could be asked to do is determine the relationship between lines if we're given their equations. So describe the relationship between lines. Alright, to do that, again, I want to know what their slope is. Well, in the first line, this is in slope-intercept form, so I can easily see that my slope is 2. The second line, however, is not in slope-intercept form. So I'm going to have to solve for y here. So I'm going to subtract 2x from the left and right side. Don't forget your negative. That's a common mistake here. I haven't done anything to that negative. Let's write our variable term first and our constant second. Alright, I want to undo this multiplication by division. Don't forget the negative. You want to get rid of the negative with the 4, so divide by both. Y equals, that's positive, negative divided by negative is positive, simplify is 1/2 minus 4. Okay, so now that it's in slope-intercept, I can identify the slope. It's 1/2. Okay, so as I'm asking myself what the relationship is, I start going through my cases here. Parallel lines would have the same slope. These are not the same slope, so they're not parallel. Okay, how about perpendicular? They are reciprocals. 2 is over 1, so 1/2 is the reciprocal of 2. So they are reciprocals, but they're both positive, so it's not opposite. Okay, so if it's not parallel, and they're not the same line, they're not perpendicular, that means they're going to be oblique. They're both rising, but at different rates, so at some point they will touch. So these lines are oblique. Okay? Alright, so we could also be asked to describe the relationship given. Here I gave you equations. I could also give you graphs. Again, you would not just look and decide what they look like, you would justify with their slopes. Or if I gave you points on lines, you would still be finding slopes to make that decision. Alright, something else I could ask you to do is to write some equations. Okay, so if I ask you to write the equation of a line parallel to this line that passes through this point. Okay, well, let's pick out the important things here. First of all, they want me to write an equation. That's pretty important. So I like to write down my slope-intercept form just to stay focused. Remember, I need the slope and the y-intercept to define a line. I lost my cap. Okay, so what other information did they give me? Okay, well, here they gave me that it's parallel to this line. So the only thing I'm interested in this equation is the slope. Parallel lines, remember, have the same slope. So I'm going to use this slope right here. Now the most common mistake I see is students want to do something with this -7. The y-intercept doesn't have anything to do with the line that I'm trying to write the equation for. But the slope does, because if the line is parallel to this line, it's going to have the same slope. Alright? So I'm actually halfway to my answer. Now I still need to find the y-intercept. Now if I'm going to use this method, which is my preferred method, I'm going to need to find the y-intercept. I will say that in algebra, if you like the point-slope formula, that you are more than welcome to use that, because now I have a slope and a point, so I could do it that way and then solve for y. I'm going to show it using this one though, because I'm not a fan of memorizing more formulas. So if I want to find b, what I have is I have the slope already plugged it in. Well, x and y, I have an x and y. Okay, if they gave me a coordinate, they're giving me a point on the line where x is -5 and y is 3. So if I substitute those in here, so let's see, my y is 3 equals 2/5 times x is -5 plus b. I can now solve for b. So over here, 2/5 times -5 is -2. And I can now add 2 to both sides. And I'm going to get my value of b is 5. Okay, kind of ran out of room here. Alright, but again, I'm not done yet because they asked me to write the equation. But I have my m, my slope is 2/5, and I have my b, my y-intercept is 5. So I'm going to write out my equation. y equals, my slope was 2/5 x plus my y-intercept is 5. Okay. Alright, let's look at the last one here. Write the equation of a line perpendicular to y equals 3x plus 4 that passes through the point -6, 2. Okay, so again, what information am I looking for? Well, first of all, what are they asking me to do? They want me to write the equation of the line. So I'm going to write down my slope-intercept form. This is my preferred method. There is another way that you can do this. Actually, just to write it down, if you wanted to use this formula, let's see, y minus y1 equals m times x minus x1. I'd be happy to show you how to do it if you come see me or ask me. Okay, so back to my preferred method though. Now that I have I know what they're asking me for, I'm deciding what I need to find. I need my slope and my y-intercept. Alright, what did they give me? What else did they give me here? Okay, they gave me a line perpendicular to this line, and it's in slope-intercept form so I can see the slope is 3. Now again, I don't care about the y-intercept. That's not useful to me at all. Now, perpendicular lines, they don't have the same slope, so I gotta do a little work here. Perpendicular lines, their slopes are opposite reciprocals. So what I'm going to do is I'm going to take 3, make it a fraction. Okay, the slope of my line is going to be, if this is positive, my slope will be negative, and if I take the reciprocal of this, I get 1/3. Okay, so halfway there, -1/3 x plus b. Alright, so I still need the y-intercept form, or the y-intercept if I'm going to use this method. Okay, I have a point here, an x and a y. Alright, so I'm going to substitute those into my equation that I've started here with my correct slope. Okay, don't use 3. I've got to take the opposite reciprocal. Y is 2. X is -6. And I'm solving for b. 2 equals negative times negative is positive. 1/3 of 6 is 2. And I'm now going to subtract 2. And I'm doing my left and right side here, so that makes 0, so I get b equals, didn't realize you couldn't see that, b equals 2 minus 2 is 0. Okay, so my slope was -1/3, my y-intercept was 0, and I can write the equation y equals -1/3 x plus 0, which is just y equals -1/3 x. I don't need to write the 0.